Welcome to EDU World Space.
This question asks us to consider three atoms, sulfur, chlorine, and potassium, in their most common ions. Part A says to list the atoms in order of increasing size. So this is just the atom size, not the ion. If we look at our periodic table, we have potassium here, number 19, chlorine here, number 17, and sulfur here, number 16. And since potassium is in a whole nother row from the first two atoms, from sulfur and chlorine, it has a whole extra shell of electrons, well, one electron in that shell, but because it's in a whole new shell, it's going to be much larger than the other atoms, so potassium's going to go last in this series. And then between chlorine and sulfur, both of these atoms have their valence electrons in the same shell, so they'll be roughly the same size. The main difference is the number of protons in the nucleus. Because chlorine has one more proton in the nucleus, it'll have a higher nuclear charge, greater pull on those electrons. Those electrons will be held more closely, therefore chlorine will be smaller. So chlorine, smallest, just slightly smaller than sulfur, which are both smaller than potassium because, again, its valence electron is in the next energy level up. All right, now let's consider the ions. The ionic forms of these atoms are sulfur 2 minus, chlorine minus, and potassium plus. Okay, so now these are all isoelectronic. They all have the same number of electrons, so the only thing that's going to determine size is the nuclear charge, or the number of protons in the nucleus. Since potassium has the greatest number of protons in its nucleus, 19 here, it will be the smallest. Again, greater number of protons, greater nuclear charge, greater pull on the valence electrons, smaller atom. So potassium smallest, then chlorine, then sulfur. Again, these are the ions. I should write those. And then part C says, explain any differences in the orders of the atomic and ionic sizes. So again, this is just because of, I'm going to write Z for nuclear charge. Whereas potassium here has an extra shell of electrons. That's why it's the largest. Other than that, the atomic charge is what's determining the size of these atoms. That's the difference between chlorine and sulfur here, and it's the difference between all three of these ions in part B.